What's going on, guys? Welcome back. Today I'm doing a video that I'm pretty excited about, actually. So long story short, that real long pause was because I changed my headphones and I can hear myself talk and it threw me off. But before we get started, guys, this is one of my most viewed videos in my entire channel. So if you're watching this, thank you. Hit that like, hit that sub button, please, guys. It helps out tremendously. And now we're going to dive into it. So this is Hack the Box Academy Linux Fundamentals. Now, if you've watched my video before, I've done this Vox. But if you notice, it says I have all these modules that aren't done. They've added a bunch of stuff to this. So I want to kind of give you guys an updated version. I've had a lot of people ask me, like, where's the next one? Where's the next one? And it's because there was no other ones until, I posted that video 2 years ago. So we'll go ahead and hop into it. I'm going to break this up into 2 videos, or try to, depending on how long it takes. I'm going to go from introduction, the shell, workflow, and we're going to stop there. And then we'll do system management, Linux, and Linux hardening. So if you guys are watching this and you're like, hey, where's the rest of it? It will be coming hopefully either the following week or later this week. So let's go ahead and dive in. So the Linux structure. So I'm not going to read you the history. You can read history if you want to. But one thing that a lot of people don't realize is, like, Linux runs the world in a sense. Windows is the main proponent for end users, right? When you think of like enterprise systems, when you think of like working in large companies, when you think of all that stuff, you think of Windows. But what you're not seeing is on the back end, a lot of stuff's running on Linux. You got your server, your Apache servers for like websites. You've got your all your different things with like your Android devices, your IoT devices, or IoT devices, your critical infrastructure. Like, there's so many things running on Linux that people don't see. So that's why it's super important to understand. Mac OS is Linux, Red Hat, any of that stuff you've heard of, and we're going to talk about distros. But the big thing here, and this is a philosophy they say, but this is a good way to think about it in general. Everything is a file. That's something once it like clicks in your head, Linux becomes infinitely easier. And it's every single thing is a file. Everything. Meaning, if you want, if you want to see how does cat, which is a command we'll talk about, run, that's a file. You can go to it. You can look at it. You can see what it actually is running when you say that. It's a binary, right? So anything that's running, you can view. Any application, anything, you can view the code, you can view it, right? And so that's something that Windows technically does allow. It's much harder to navigate Windows and find those things, and there's hidden files, and there's hidden files in Linux that we'll talk about. But Linux, when you think about it, everything as a file, it makes sense. You'll start to see as we progress through it. Think of everything in Linux as a file explorer, like your regular directory on Windows if you're used to Windows, right? So small single-purpose programs. This is what makes Linux so useful in large settings. Is these are single-purpose programs. It doesn't have all that bloat that Windows has a lot of times, right? This program offers many different tools that we'll work with, blah, blah, blah. Usually, if you're designing something in Linux, it's for efficiency. It's not to look pretty. It's not to, yes, there are tools out there that have like a nice GUI interface. It's so nice and da. But most people that put any effort into Windows operating systems as far as system development and stuff, they're trying to get efficiency out of it. That's why they're using Linux, because it's lightweight, it's simple to set up, it's easy to harden if you know what you're doing, and it's very, very useful, right? So ability to chain programs together to perform complex tasks. So again, it allows us to take those simple tasks. That's what all Linux is, and that's what all computing is. But on Linux, it's just simpler. It's just easier to see. And it is taking all these minute tasks, chaining them together, and creating a very efficient thing, right? And Windows does this too, but Windows has a lot of bloatware. It has a lot of stuff that runs that doesn't really serve a purpose, but it's like nice. Like an example is the print spooler service, right? That's an example on every Windows computer it runs. Are you printing all the time? Not necessarily. So does it need to be running all the time, right? Not necessarily. And Linux has there's all these different distros with different versions of things like that. But just know Windows has a lot of stuff that's running that's not needed. And Linux takes that and then basically compacts it and makes it much more efficient. Avoids captive user interfaces. So again, we talked about this. It's mainly designed to work in the shell. It's designed to work on the command line. Super simple, super easy, and quick, efficient, that type of manner. Configuration data stored in a text file. So if you have any sort of configuration file, right, any way that you need to program something, change something, configure any of that, it's stored in a text file. You edit the text file, it's now reconfigured, right? In Windows, it's not that easy. It's sometimes very complex to change that, and Linux makes that super simple, right? This is an example, right? Etsy password, we'll talk about that file, but it just stores all the users. Hey, awesome. I know how to find all the users now. In Windows, do you know how to find all the users? You can go, open up users and computers and all that stuff. But in Linux, you just go to that file. Real easy. Everything's a file. Remember that. We're going to keep saying that. All right, components. You got your bootloader. And if you guys have ever worked on any computers or anything like that, the components are pretty much the same on Windows. But you got your bootloader, right? You got a piece of code that runs, telling it what boot process to run, right? Do you run, what hard drive do you look at? Where's the boot configurations, all that stuff, right? You got your OS kernel, and this is going to depend on what OS you're using. We'll talk about the distros, but you're going to say, hey, this is the kernel, right? The operating system. It's going to actually manage those resources that your computer's using. Then you have your daemons, right? Background services. This is what I was talking about, like the print spooler service in Windows, right? It's a background service. It's running, but you're not seeing it up front. You're not watching it run right now, right? So you have your daemons. Their purpose is to ensure that key functionalities such as scheduling, printing, and multimedia are working correctly, right? And that's an example where I was saying like the print spooler service runs on Windows. Does it need to run all the time? Not necessarily. It only needs to run when you're going to print, right? And so this is where it would run in the Linux portion, in daemons, right? Then you have your OS shell. So this is the shell that you use. You can use TC shell, CS shells, K shell, Z shell, Fish, Bash shell is probably what you're most likely going to use. And really what this is this is the interface that you're going to use that tells the operating system what you want it to do, right? To actually control it. Bash is what you're probably going to use most of the time. It used to be common like T shell or TC shell and stuff. I used to operate on the C shell and stuff like that. I haven't really in years, to be honest with you. I just haven't ran into it. Doesn't mean it doesn't exist. Doesn't mean that there's plenty of operating systems. When I stopped working for the DoD, I stopped using a lot of these old shells, and so some of them still are around. Obviously, it's just almost everything you see now has some sort of bash or variant of it, or just a shell or whatever. Doesn't really matter. Graphics server, right? This provides a graphical subsystem server called X or X server that allows programs to run locally or remote on the X windowing system. Now, one thing you'll know is when Linux is not known for its graphical, astounded, graphically sound components, right? In the sense of you're not going to see a lot of like heavy duty gamers using Linux. Nothing against it. It's just not designed for that, right? Linux is very difficult to make really complex systems work together unless you really, really know what you're doing. And so when that happens, and I know we said earlier that, hey, actually complex systems work really well together. It does on the simplistic basis. When you start getting like a GPU that isn't compatible and you need driver specific, but you need to also have them on Linux in specific areas and have the configurations changed and all this stuff, you have to really, really know what you're doing. So understand that it's not typical. It is possible, but it's not typical to see really graphically intense computers running Linux if they're using it for that, right? Window Manager, right? Also known as the GUI, right? This is the one that actually lets you see a desktop environment. A lot of Linux servers don't have this. If you're looking at like Ubuntu and stuff like that, you're going to see that they have it, and it's really nice. But a lot of servers don't really have this. They just have command line. That's it. Utilities. Applications or utilities are programs that perform particular functions. So utilities are things that you're going to use throughout your day-to-day life, and then they work really well and they're efficient. All right, now Linux architecture. This is the nice thing. It's all a file system, right? So we have our hardware, peripheral device such as your RAM, hardware, same thing as any other computer, CPU, blah, blah, blah. Your kernel, this is your core operating system, right? It's used to virtualize and control common computer hardware. So it's used to actually tell that CPU, that GPU, all that stuff, what it needs done. You have your shell. This is how you interface with it. Then you have your system utility. This makes available to the user all of the operating system's functionality. So your system utility are the actual commands you run that actually tell the shell, right, is how you interface. It tells the kernel what you want it to do. Now, when I said everything's a file system, I quite literally mean it, right? Here is what it looks like. You have your bin, you have your boot, dev, blah, 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 all this all the way down. And keep in mind, anyone that's ever used Linux, multiple different OSs or versions, whatever you want to call them. Some people call them flavors, some people call them distros, some people call them OSs, whatever, it doesn't matter. They don't all have all these directories, so just know that. I actually used to know really, really in depth the directories, like what the history of them all and stuff. I don't really remember all of them. So I'll give you my best, of what I know of them, but just know that I used to know the history, and some of them, it is pretty fascinating, the history of Linux. If you ever look it up, it is actually pretty cool, because some of these you might say like this one, the etc file, right? You might say oh, that stands for etc. But the history of it, if I remember, was they didn't have a name or something. It's pretty cool. It's pretty interesting. I'm kind of a nerd when it comes to that stuff. So you have this / right? That's the root directory. This is the baseline for everything. You can see that's when they say Linux file system. This is like your C drive on a computer, on a Windows, right? It's everything. So it's the top level directory. If you go to the root, everything's below it. Then you have your bin, which is binaries, right? Contains several essential command binaries. This is where the main binaries are stored. Boot, obviously, what's it sound like? It's where most of your boot stuff is stored, right? The bootloader, the executables, blah, blah, blah. Then you have your dev, contains DEV. Dev stands for devices here, not development. So just know that. Contains device files, to facilitate access to hardware devices. So this is where you're going to, if you have a USB or something like that you need to plug in. And keep in mind, the big thing about Linux is you can do anything anywhere. Meaning, if I plug in a device and I'm I don't want to mount it to dev, I want to mount it to lib or lib, right? Library. I can. You can do whatever you want. That's the nice thing about it. So just know that not every machine you get on is this going to make sense. You might get on them and be oh, I'm looking for devices, and you find them under home, and you're what the heck? That's not where it goes. Understand that it doesn't really matter. This is just what they built the directories for, right? So now you have etc. That's what most people call it. It actually, if you look at the initials, is etc., but most people call it etc. And this is your local system configuration files. Configuration files for installed applications may be saved here as well. So when you're looking for actual config files for the system, not for applications you download or anything like that, look in here. Now, home. Everyone that has a directory or that gets a user account on a Linux machine has a directory under their home or under home. So if I had an account, it'd be Stuffy. It would be under home, and that would be my home account, and I'm the only one that has access to that besides root. And so this allows me to actually kind of store my stuff. It's kind of like if you go to My Computer users or C drive users, that same thing on Windows. Library, shared library files that are required for system boot. Media, external removable media such as USB drives. So I lied to you before. I forgot about the media one because not every Linux distro has that. But devices, this is more of your hardware devices, whereas media is your external devices that are media, like USB, SSDs, that type of stuff. So I do apologize. I had that wrong. Now mount. Temporary mount point, right? So this is where if you need to mount something to access it temporarily, like another drive or another hardware or hard drive or something, you can mount it here, and then you can do whatever you need to do with it, and then it's a temporary mount system, right? You're not permanently leaving there. You could, I guess, but then you have opt, right? Optional files. So this is where you have your third-party tools. So if I download or install something or use GitHub or any of that stuff, this is where you typically want to put them, just to keep it organized. Then you have your root. This is the home directory for the root user. So exactly like we talked about with the home directory for every user, this is the same thing, but for the root user. You have your SBIN, which again for binaries, right? System binaries. That's what S, right? This directory contains executables for system administration. So if I need to run specific binaries for system administration, this is where they'll go. Temp. This is a temporary directory. So anything that goes in here gets completely deleted and blah 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 when you restart the machine. So just know that if you put anything in here, it's probably going to be deleted at some point. User contains executables, libraries, man files, etc. Then variables or var directory contains variable data such as log files, emails, inboxes, web applications, blah, blah. So this is your general general directories. Keep in mind you can have more or less depending on as you go through them. Now, Linux distros. So I'm not going to go through every single distro. You guys can feel free to read about them. Ubuntu, Fedora, CentOS, Debian, Red Hat. They're all very popular. Parrot OS, that's what the attack boxes are on here. Kali Linux is the attack box on whatchamacallit, Hack the Bot or Try Hack Me, excuse me. That's probably why they don't have it on here, is because it's used by a competitor. But both are good distros for hacking. Many users choose Linux for their desktop computers because it's free, open source, and highly customizable. This is true. Most of people don't even realize Windows has a pretty hefty price tag just to have. It's $100 plus just to use it. You don't realize that when you buy a computer because you're paying for it with the computer, but if you go buy Windows, it's $100, right? Linux is free. You can see Debian is the most widely used and well-respected Linux distro, known for its stability and reliability. This is true. Parrot OS is Ubuntu, Debian, blah, blah, blah. And you can see, now they don't talk all about it, but you can go through and you can actually kind of pick your poison, if you will. Like if you just use Ubuntu, well, guess what? It's Debian, okay? So here's your Debian. You can actually download just plain Debian is what they're saying, right? You can use it. A lot of these are built on the back end of Debian, meaning if you go to like Kali or Parrot or whatever, and I don't know them all, so just bear with me. Ubuntu actually has a GUI and everything else, so it's a little bit different. But if you just use Debian, that's a Debian vanilla, if you will. That's really good, but understand that like Parrot and all them are built on a Debian backend. So all that means is they've kind of taken that Debian version and they've customized it to a way that they found suitable, and then I'm saying reselling, but they're not selling it. They're giving it away. But that's what a lot of Linux distros are, is just variations of a distro that basically they didn't like. They said, hey, it's open source. I like specific configurations. I'm going to configure this the way I want. And then if you like it, cool. And that's what Kali began as, when it became a hacking distro, was they put all the hacking tools and stuff on there, and people were like, oh, this is awesome. And they're like, thanks. Here, we'll just make it now, right? So, okay, introduction to shell. It's crucial to learn how to use Linux shell. This is true, and nowadays you see a lot of people using just like Ubuntu, the GUI interface, and they're like, I know Linux. Be careful, because if that's how you know Linux and you actually get to a location where they use Linux, then you're not going to know it, because if they use Linux and they use command line, like most servers only use shell, you're going to struggle. So make sure you know the actual shell, right? Terminal emulators, this is where you're going to see a lot of times it allows the use of text-based programs with a graphical user interface. They're also called command line interfaces. Basically, they're emulating the terminal, right? So imagine you're in a large office building where the shell is the main server room that processes all the blah, blah, blah. The terminal is like a receptionist desk that serves as a point of communication. Now, suppose you're working remotely. Terminal emulation software acts like a virtual receptionist. So what they're saying is you can emulate that terminal. It's not the actual terminal, but it will do what the terminal wants, right? So then you have your shell. The most common is Bash, which is born again shell. Everything we do through the GUI, we can do with the shell, which is true. And I actually recommend you do it through the shell. The reason I'm skipping through this is we're going to do almost everything on the shell here, so you might as well just see it. Okay, and you can see this. Okay, so it can be customized. This is true, but understand this is not necessarily default. But you'll see it'll have the one that they're going to present us with is going to have our username. Then it's going to have host name, and then the current working directory. That's just informational, so you'll see that. Then you'll have this $sign. Anything after that is what you're actually typing. So, and then you can see this little tilde, I think, and that tilde means you're at the home directory. So if any point you need to go home to wherever your default directory was, you just type the tilde, you say CD for change directory, and the tilde, and you'll go home. Okay, so this is what it looks like. They're the root user. They're on the machine hack the box, and they're in the current present working directory is /hack the box, right? And then they have here the hashtag, which all this does is you can see it means that we are logged in as root. Perfect. Unprivileged, $, privileged, hashtag. It's really important to see the difference because when you're working, especially on Hack the Box, sometimes you can get lost in where you're at, especially if you have a not a fully interactive shell and you like are accessing the shell and you actually don't realize who you actually are at that point. It's really nice to be able to tell that. So the PS1 variable in the Linux systems controls how your command prompt looks in the terminal. This is actually kind of confusing if you guys use PowerShell, because that's, if you use PowerShell, you read that, you're like, huh, what are they talking about? But the PS1 is what actually controls what it looks like. So you can add all these things is what they're saying. And you can make your shell list all the information for the computer right here if you want. You can dive into that if you guys want to. That's more customizable, more aesthetically pleasing. It's not necessarily something that you have to know. And you can see they have a bash prompt generator and Powerline, which gives us the possibility to adapt our prompt to our needs. Okay, so again, that's all aesthetically pleasing, and that's great. But getting help, this is kind of the bread and butter of Linux. You don't need this as much anymore, but like when I was working in data centers over a decade ago, right, you really, really needed to know this because you would run into this all the time, because data centers, especially for like DoD, you couldn't have cell phones, you couldn't have any of that stuff in there, so you can't look anything up. So we would have to use the man pages. That's what they're called. So you would see that they're typing ls for list. That's your first command, right? Ls, it lists the directory contents, everything that's in there. And then you could see man, and then they're typing man, and then they just have a placeholder for tool, but we used ls, so they typed man for ls. Man stands for manual pages, right? So think about anytime you're like, hey, I need help. Think about, I need to look at the manual. That's the best way. I need to look at the manual. Type man ls, and you'll see it gives you the breakdown of everything on this page of how to use it, right? ls, it tells you how to use it. It tells you name is list directory contents, ls. The ls, the option, and then the file if you want. And then they didn't scroll down all the way here, but if you scroll down, it actually gives examples, shows like how you use it. So there's a ton of information in here. So I recommend you guys, if you're ever stuck, look at the man pages. They are a lot, but if you read through it, you will find, I almost guarantee you'll find what you're looking for on how to fix something. Yes, you can do this, tool//help. But understand, if you download third-party tools or use like GitHub pages and stuff like that, they don't all have the //help or the -- help, right? And by the way, if you guys hear me call that attack, the dash, that is attack. That's what I call it. So I try to avoid saying it because people get confused, but that's what I call it. So you can see here they did ls -- help or -- help, and you get the same thing, right? It's a little bit different, but pretty much the same thing. Keep in mind, not everyone will have that, so understand both ways because you don't want to get stuck. And then the attack H as well, which stands for help. Sometimes you'll do like attack H and you'll say, hey, we don't understand that command, and it'll give you a little bit of help, and it'll say use -- help. So just as long as you know kind of how to get help, you can find what you're looking for. I almost promise you that. Okay, so as we can see, the results from, this is from curl, okay, from each other do not differ in this example. Another tool that can be useful in the beginning is apropos. Each manual page has a short description available within it. This tool searches the description for instances of a keyword. So if you know, hey, I have like something specific I need to look for, it can actually do that for you, right? So you can see they typed in sudo, and here it searches the contents and gives you kind of a brief description. Pretty easy, pretty self-explanatory. If you need help, if you have access to the internet, you can find the help as well. So don't die on that hill, right? Okay, so this one, it's starting to show information. So let me go through here and start the targets while we talk about it. Okay, so we're going to go through basic information here, right? We're going to go through who am I, displays the current username. ID, this returns the user identity. Host name, set or print the name of the current host name. Uname prints basic information about the operating system. Okay, so far pretty simple. One thing I will tell you, and I've talked about this in my previous one as well, is you don't need to memorize all these. Look at this. Oh, look at that. I can copy and paste that and keep it as a cheat sheet. You don't need it. There's cheat sheet up here. You don't need to memorize everything. Linux comes from using it over and over and over again. What that means is if you use it over and over and over again, you won't have to memorize these because you will memorize them on accident. I promise you. I can promise you you're going to use these enough in your career if you're in cybersecurity that eventually you're not looking at that cheat sheet anymore. But until then, keep that cheat sheet right here. Who cares? All right. PWD, present working directory. ifconfig, used to assign or view an address to a network interface. Okay. IP's utility to show or manipulate routing. So some of these are old school, like ifconfig. You can still use it. Netstat shows network status. SS, utility to investigate sockets. PS shows process status. So this is where if you work with Windows a lot, you may be like, oh, that starts a PowerShell. Nope, that's processes. Who displays who's logged in. ENV prints environments or sets and executes commands. Okay. LSBLK lists block devices, lists USB devices, lists open devices, lists PCI devices. All great things. But again, don't die on this hill and memorize them. I promise you, you won't need to. You can look them up at any time. Okay. You can see here, Secure Shell. So they're talking about SSH, which is actually, it's called Secure Shell, but it's a way to remote manage this server or computer, whatever you want to say. And you log into it using Secure Shell, and you actually have a shell now with an encrypted channel where you can control that shell, right? So that's really what you're doing here. All right. So they're telling us how to use Secure Shell. Then they're telling us, hey, let's check host name. They've got Nix Fund. That's what the name of it is. Who am I? They got Cryolite, I guess. ID, and you can see you get the actual user ID, you get the group number or numbers and all that stuff. So you get, and then they have Elite Hack the Box. Okay, so you can see the ID command expands on who am I. Who am I is the simplistic version. If you just take over a box or something, you're like, I don't know who I'm logged in as. That's where you're going to use who am I, because you're just like, I just need to take a quick check. ID would be you need more information than that, right? So this can be of interest to a penetration tester looking to see what access a user may have, right? So you can actually see their group ID and all that. In this output, Hack the Box group, boom, with the Elite is of interest because it's non-standard, right? When they say non-standard, it means it's not normally there. Someone created that group. That means they probably created it for a reason. You probably have some additional permissions that the other groups don't have. The ADM group means that the users can read log files and var log, potentially gain access to sensitive information. Perfect. Membership in the pseudo group, is of particular interest because that means you can run things as admin, which means you can probably become admin. Okay. All right, uname. So let's dig into the uname command, and you notice they typed in man uname, so they're actually looking at the man pages. And they get all this information. Great. And they say uname tac A. Well, if you look here, uname tac A says print all information in the following order. And you can see we've got Linux box 4.150 generic, number 100 Ubuntu, SMP, blah, blah, time, architecture, all that stuff. So you get a lot of information about the system. Awesome. So we've got the kernel, we got the host name, we got the release date, the release, which is really important because we know now what security updates do they have. Well, we know because of that's their release, the kernel version, all that stuff. So now, suppose we want to print out the kernel release to search for potential kernel exploits. Well, you can type in just uname tac R. You don't need the uname tac A, right? Okay. With this information, we could go search for that exploit and first result, and we could take over that box. That's what they're saying. So let's go ahead and dive into it. So it says SSH into this machine, right? So just copy that. I'm going to make this full screen because I know it's a pain in the butt to see that. And we'll make this bigger for you guys. And we'll say SSH. I don't know if they gave us a user. Hack the Box student. Okay. So Hack the Box student at Okay, it didn't copy. So 10, 129. $237, 44. Okay, and then the password is Hack the Box Academy student. Let's see if I can actually get to copy and paste. Yes. Did it work? It worked. Okay, we're in. And you can see we're Nick's Fund. So find out the machine hardware name and submit it as the answer. So 2 things you can do here before we dive and start doing this. You can look at the hint, right? And it'll say, take a look at the uname utility, right? So, or you could go up here and find right here, uname. And if you remember, you can actually do this one. Where is it? The hardware name is TACIM, which is what they're asking for, right? Find out the hardware name. So we can say uname TACIM, and we get x86_64. There you go. What is the path to the Hack the Box student's home directory? Well, one thing we can see here, we can see that tilde. That means we're in the home directory. So now we just say pwd for present working directory. And there you go. Home, Hack the Box student. The other thing is you can also assume that based on when we were going through the module, it said anything after home will be a user's home directory. So we could assume if we know our username, there you go. What is the path to the Hack the Box student's mail? Well, this one, if you remember going back to var, right? We know that the variable here stored our mail inboxes. So you go cd mail, and cd, by the way, changes directories, right? And you can see this one would be our username if we had one, right? So we say, and it looks like, funny enough, this one actually says it, but there is no mailbox in there, which is fine. They may not have anything set up there, but that's where it'd be based on what we learned before, that everything's under the variables or var, right? And then var mail. Now, which shell is specified for the Hack the Box user? So let's go back to home, right? And we already said that bash shell or bin bash, which is born again shell, that's going to almost always be what we're kind of working in, especially in Parrot. And we know that this is Parrot OS, so it's safe to assume it is bash. Now, here's the thing. A lot of people get on my channel and they'll say things like, well, how did you find that? I'll be honest with you. I didn't, because I don't need to, right? And I don't mean that insultingly. I mean, if I am confident that I'm using, this is Parrot OS, right? Which I am, because that's what they use, or at least last I checked they use, right? And I'm confident that Parrot OS uses bin bash, I can put it in there, and if it works, awesome. If not, then I will go find it. The reason I do it this way, because I understand this is not the way the box is necessarily intended. I understand that you guys are going to say, well, you were supposed to go here, and that's how you find it, and you just guessed, or you cheated the system, or whatever. That's what hacking is, okay? Understand that hacking is just doing something differently to get a result, right? If I want to take over a machine, guess what? The intended way to do that is log into the machine. I don't want to do that. I want to do it a different way. So I'm doing unintended things using the system, right? So understand, I have no problem if someone's like, I don't know how to find this. Let me put it in. Why? Because that's just problem solving. Meaning, if you said, okay, don't do that, you could probably figure it out, right? So understand, if you see me do that, don't assume that I can't figure out. I could go right now, hey, how do you Google what's the way to find the bash shell, or find the shell on the machine, right? Super easy. It would tell you probably check bin bash, right? Okay, cool. Or I could just take the knowledge I have, explain it, and then attempt it, right? So which kernel version release is installed on the system? Well, going back up here, we're looking for the kernel, and you can see S is the kernel name right here. Uname TAC S. and I didn't mean to do the additional. Okay, so the kernel name is just Linux, so we're looking for the kernel release or version, so V. And we could do A for all. Okay, that's Ubuntu. So what is it asking for? Because I thought it was the kernel release, okay? Well, let's just do all then. All right, and there it is. 4.15.0.123 generic. I must have typed it wrong. 4.15.0. There you go. And yeah, I probably just typed it. Yeah, I did V instead of, I did version instead of release for some reason. Okay, and then what's the name of the network interface? That MTU is set to 1500. Well, if we go up here and we look, we can look at IP, right, or ifconfig. We can look at either one. All right, ifconfig, and we're looking for the interface, which there's MTU 1500, which is what it actually said, and there's the interface name, ends 192. Ends 192. Perfect, easy enough. Let's go on to the next one, right? Okay, so this is called workflow, this section. So navigation is essential, right? So how do we get around? Personally, this is kind of where you lose me a little bit if you're hack the box. I've talked about it before, but they have really good content and they do stupid stuff with it. Like this one. You're now going to teach me present working directory, ls, cd probably, etc. But you just made me have to do all that to get the answers to the previous section. So if I was here, I'd be lost. But if I go through this navigation first, then I understand how to get around, then I'd figure it out. So if you're doing it that way, I apologize. I didn't make the box. I'm just reporting on it, right? Okay. So now you have PWD for present working directory. We talked about that. LS, it lists the contents, right? Excuse me. The ls tac L option to display more information on these directories, right? So it displays, the permissions. Actually, it shows it right here. So the permissions, and we'll talk about these permissions as we go on. Then it displays the number of links to the files, right? Then it explains the owner, then the group owner, then the size, and then the date, and then the desktop. Or sorry, the desktop, the directory name, right? So what directory is it? Perfect. Okay, so again, do you have to memorize that? No, you'll use ls tac la enough times that you'll probably, and you can see there they actually mentioned the la. That's typically what people are going to do because it shows hidden directories. Anything with a period in front of it means it's just hidden, right? This is very common for system files and stuff. Windows does the same thing. They just you don't need to see everything. So use ls tac la and you'll see these hidden files as well, these period files. And there's nothing wrong with seeing them or not seeing them. It's just you need to know that that's how you find them, right? Okay, so to list the contents of a directory, you don't need to go into the directory, meaning you can ls a remote directory, right? Or a directory that you're not in that current directory, and you can still list the contents just fine. Okay, now cd, change directory. CD, change directory. Just try to remember it that way. If you can't, no worries. It takes 2 seconds to Google that, figure it out. We can quickly jump back into the directory we were last in by cd space tac, right? That will jump in the previous directory. So if you went to a directory, you're like, crap, I need to go back, cd tac, you're back, right? Now, you can do this, cd whatever, start typing, and then tab, and tab will autocomplete, meaning it will actually fill it out automatically for you. If there's multiple, if you hit tab twice, it'll show you the options, right? So if you're like really deep into a directory and you're like, I don't remember the exact path, I can hit tab twice, it'll show me the options. It's very nice. If we add the letter H, right? So all they're showing here is that it's going to autocomplete versus show the options. That's what they're showing. Now, CD period. This is really important because a lot of people know that CD period takes them back a directory. They don't really understand why. And I think it's really important. So we will go here and show it. So here's the big thing. If I say ls-tach-la, right, you can see every directory has this period and this period, right? The period 1 is the current directory you're in. Remember, we said everything is a file, everything. That means the current directory right now is this file right here, right? This period is the previous directory. So when you're saying cd period, you're actually referencing this right here in the directory and going back. So it's important that you understand why. I don't think it's necessarily important because I think it adds a ton of value. I think it's important because if you don't understand what you're doing, you're just kind of doing stuff and you're not actually growing. So that's just me, right? Okay, now they're showing you here, since our shell is filled with some records, we can clean them out. Yeah, that's great. They're actually going to cd into this shm, and then they're going to hit clear. So if you do and, it's just going to say run this command and that command. So they're actually just saying change directories into this and clear it out. That's all they're saying. Okay, what is the name of the hidden history file in the Hack the Box user's home directory? Well, lucky for us, we actually just went in here on accident, right? So it's .bash history. Now, that bash history file, actually, funny enough, if you open it, cat.bash history, well, the only history they have is exit, but it stores the history of your commands you're running. Okay, now what's the index number of the sudoers file in the etc directory? Okay, the index number, so we'll just say ls-tach-la, and it was sudoers file in the which directory? I didn't etc. We don't even need to do that. We can just do that, right? And we need the sudoers file, right? And okay, and let's make sure. What's the next number? The sudoers file in the etc directory. Okay, so we found it. Now let's just cd into it. Okay, and now let's go look at. I hate my mouse, by the way, because it just, I don't know why it does that, right? Okay. And this is, so I think I had this problem with Hack the Box or before, is it says stuff like this. What is the index number of the sudoers file? So let's say how command to get index number Linux. And it's really annoying because they didn't show you that. Okay, and it's tach-i. So they wanted you to go and actually say ls-tach. And I'll show you guys, you can do ls-tach-ala and I. And you'll get it all. And you get the index number plus the permissions. But it's, and by the way, that's how quick a Google can be. Do I memorize the index number command? I do not. So here's the sudoers file, 147627, 147627. Boom, easy enough, right? But it drives me nuts because what they're trying to do, I understand. They're trying to make sure you actually read the man pages and stuff like that, but don't walk people through it as if this is all the information you need and then go, gotcha. Like, say, you're going to need to review the rest of this or you're not going to be able to answer these questions or something, because they do this all the time. They display all the information and the questions don't make sense, and it drives me freaking nuts. Okay, so now working with files and directories, create, moving, and copying. So touch, if you've never heard of touch is a command that in this case they're going to probably use it to make a file, but it actually just physically touches a file, meaning if I go and look, all right, so if I go look right here, this file xdg, well, that's a directory, wget-trc, right? See the date, April 8, 2019. If I have permissions, which I don't know if I do, wget-rc, right? And I touch it, yeah, I don't have permissions. So we'll go cd home. I'll have permissions to anything in here. And I say touch. You notice the bash history says 5 September 23. I'll say touch bash history. And now when I do it, the bash history has today's date. It literally just touches it. If you notice, I'll say cat bash history. Nothing changed inside of it. It just literally touches it so that that date changes if you don't have it, or if the file exists. If the file doesn't exist, it creates one, an empty file with that name. So understand that. Now, a lot of people do that to, like, if they want to just create a file that they're going to put stuff in or whatever later, they'll use touch. Now, mkdir, make directory, right? This literally makes a directory, whatever name you want. In the current directory you're in, it will make that. So in this case, they're going to use a file called info text, touch info text, make directory storage, and then they're going to say, when organizing your system, you may need to create multiple directories. So here they're going to make a whole directory tree, which it looks like they're going to make storage, local, users, documents, and then I'm assuming they're going to put that file in there. So yeah, so they're saying make dir parent storage local user documents. Okay, cool. They're showing you a breakdown here. This is what it's going to look like, right? Info.txt, that's the file they created. But then they created storage local user documents. Now, when they actually go through here, you can see now they went touch and they went all the way through storage local users info.txt. It will create that document. Now, when they look at the tree, they have info text because that's the one they originally created, the storage local user documents, and then inside that is the info.txt. Okay, now with the move command, mv, right, we can move and also rename files and directories. Okay, so they can move. In this case, I'm going to skip the syntax and show you mv, info.txt, and information.txt. So all they did here is rename that file. It looks like they are moving it, but they just renamed it. They just said move info.txt to information.txt, which is just renaming a file. Now touch readme.txt, they create it. Then they said, hey, move information.txt and readme.txt to storage. Now if you look, go into the tree, you have storage, information.txt, and then here's your readme.txt, right? So it just moves them to whatever contents you want, which in this case was storage. Okay, now CP, copy, right? Storage readme.txt to storage local, and then it'll change it to local readme.txt. So you can see if you look at tree, they said storage, and it used to say storage readme.txt, right? And now it says storage, there's the readme.txt, but then under local, there's a readme.txt because they CP copied it, right? All right, so now what do they want us to do? Let's see. What is the name of the last modified file in the var backups directory? I don't know what that has to do with the copying and all that stuff, but we'll take a look. So we'll say ls tac la, and it was, what was it? Last modified file in var backups. Var backups. And you can look at the date, and this is November 11th, November 12th. There you go. Let's see what the answer is. APT extended states. Yep. And the reason that is because you'll see there's actually, where'd it go? There's actually right here 2 things that were edited this date, but one of them is a zipped file and one's an actual file. So they're saying the last modified file, it's that one, the APT extended status. What is the inode number of shadow.back? Like, what do they talk? Like, here's the thing. No problem with them doing that, but how do you go from, hey, here's how to copy and move files, to what is the shadow.back file? What is the inode number? Well, let's see. What command for inode number on file Linux? And we'll find out. Okay, so ls tac a, we're back to it. All right, so we'll just say it's under var backups. ls tac I var backups, and we're trying to figure out the shadow.back 265.293, 265.293. So questions had absolutely nothing to do with moving files, copying files, any of that stuff. But there's your answers. Now, editing files. This is where it gets a little more complex because of the fact that Nano, VI, Vim, all of these text editors that Linux has are a little bit more complex than like your Microsoft Word or something like that. They're very easy once you figure them out, but a lot of times they take like cheat sheets just to get used to it. So Nano is what they're showing us here, Nano notes.txt. So here they're opening a file called notes.txt, and they're going to make their notes. They're going to type just like a regular text editor, and you can see they have these Control G, Control X, Control blah, all that stuff to actually move the cursor around and all that stuff. You can use the arrow keys as well. There's a lot of different shortcuts here, basically, right? And then you can see the caret stands for control. Yep. And then if we press Control W, that is where is. That's a search. And then you can actually search for something if it's a large file, etc. All right, here we can type everything we want to make our notes. Search and it shows you where it is. Okay, after we have saved the file, we can leave the editor with Control X. Okay, so you can save the file by hitting Control 0 or Control O, excuse me. So again, just know these. You don't have to memorize these. Just look up the Nano cheat sheets. There's all kinds of them. Now you can see cat notes. Once they edited it, they actually catted it, and there you go. Their notes just say, here we can type everything we want, make our notes. You can see that there's a lot of text here, but all they've added is this part, right? And that's all you're going to see in the actual thing. Now, historically, the etc password file also stores the password hashes. It does not. It stores the shadow, or the shadow file stores the hashes. They're saying historically it used to. So no, the etc password just has the users in it now. Okay, now Vim, and what they're saying here, the etc password file, the reason it's so useful for people is it's globally readable. And so that means that any of us can actually go read it, which means if I'm testing, if I can get access to a machine or something like that, that is a known variable that won't change, and I can read it. I can always reference it, and I will know if something worked. That's really what the big value is in it, besides the fact that you get the user accounts. But okay, Vim. So Vim is modal, gee, many Christmas, is a modal editor that can distinguish between text and command input. Vim offers a total of 6 fundamental modules that make our life easier. This is true, but keep in mind, if you don't know how to use Vim, you're going to need a cheat sheet for sure. So normal mode, all inputs are considered as editor commands. So this is how it starts up. It's going to start up. It's going to be thinking everything you're typing is a command. You have to type I or hit I, right, to insert, and this is where you start typing stuff. Visual mode is used to mark contiguous part of the text, which will be visually highlighted. And then command allows us to enter single line commands. And then replace, this is exactly what it sounds like. You're going to replace stuff. Then EX emulates the behavior of the text editor to exit. Vim tutor, right, is something to practice with the editor, because nothing screams use my text editor like I had to create a tutorial for you to figure out how to use my text editor. Don't get me wrong, Vim and VI have been tremendous in my career. I love them, but there is a learning curve. I use Nano unless I need to use Vim or VI for something, right? So understand that. There's no questions on that one. Let's keep it moving. Okay, find files and directories. This is going to be one of the most vital things that you're going to probably do, and that is finding files and directories. So one of the things, how do I know if something's installed? How do I know if I can use it, right? Well, which, that's the word, right? One of the common tools. This tool shows the path of the file or link that is executed, right? So if I say, when I type Python to run a Python script, what's running? When I type curl, when I type netcat, when I type cat, when I type ls, what's running? It's going to show me that path, right? That's really important, because guess what? What if I'm trying to use Python, but it needs Python 3? And every time I type Python, it's not going to Python 3, but I have Python 3 installed. I need to change how I do it, right? Or I need to directly use that. Now, find. Find is exactly what it sounds like. It actually finds the files. This is where it can get complex. Look at that find command. You might say, whoa, that's way more than I thought it was. Well, guess what? It's not that hard. It's just hard to understand initially. So find, they're using the root directory. That root directory means search the whole computer, because that's where it's going to start search. Type is F for file. I want to search for a file. The name, I want it to be a wildcard, so anything.config or .conf, so any config files on the root directory that are a file, that the user is root, the size is plus 20K, right? And then, I don't know, newer than 2023.3. I don't know the date on this box, so I don't know how old that is. And then execute the ls.al command, and then this gets confusing, but the 2 dev null, this tells it so when you run any type of command and you're not root on the box, you're going to get errors when you're searching the whole box. You're just going to get errors. You're going to get permission denied all over because you can't access those files. So you do the 2 dev null, because 2 is an error code in Linux, and it sends it to dev null, which means just don't show them to me, get rid of them. And so it prevents you from having a screen full of errors, and you have to go through and try and find these, the files in there. Now you look and you can see, now you have the autoconf, the tri-state conf, the repeats, all these. So now you have all the configuration files. That's a long way of saying exactly what I just said. They laid it out for you because they executed on there the ls. That's why you have the permissions here as well. So really good one-liner here. If you've never used this, save it in your notes. Just change it for what you want, and it's a really good way to locate stuff and find files on your machine. Locate. It will take much time to search through the whole system for our files and directories to perform many different searches. The command locate offers a quicker way to search through the system, in contrast to the find command. Locate works with a local database that contains all information about existing files and folders. Okay, so you can update the database, sudo update database, right? If we now search for all the files with the conf, right, you will find that the search produces results much faster than using find. Yeah, it does, but you have to keep that updated, right? If you don't keep it updated, doesn't matter. Now, it's funny. There used to be a trick, and I bet you any of you Linux admins out there, people used to do this themselves. They would take an entire backup of the names. I've done it a few times, and I used to do it when I was a Linux admin. You would take a complete backup of all of your names of your files and stuff and store them in a file like that. So then you could use something like grep and just quickly search for them. And it was not the best thing, but I'm glad they've added the locate to actually get rid of that functionality and save us the time. Now, what is the name of the config file that has been created after 2023 and is smaller than 28K but larger than 25? Well, we can just take this little one-liner here, go back down, and we can say, we'll just do it right here if we can. So we'll paste this, okay, and we'll say, what is the name of the config file that's been created? So same thing, created after 2020. So we don't need it to be any user. We need it to be smaller than 28K but larger than 25. Okay, so smaller than 28K but larger than 25. So let's just do plus 25K and just see how many we get, right? And same thing. Let's see how many we get here. So, all right, so we're getting a decent amount. All right, there's our file right there, Mesa defaults. So we could just stop there. There's only 4 to search for, or 5. But all we would do is say we want it to be plus 25K and less than 28K. And no, that didn't work. All right. We'll just do this. Size 25K, 28K. Let's see if that works. It might just be 25 to 28K. That didn't work either. That's all right. We found it here. I could just go through, I just Google this real quick to see the size parameters, or I could use the man pages, but we found it anyway. There was only, so this is a little trick I do to save myself time. If I don't know the command right off the top of my head, I will actually just run it if I know it's only going to produce a handful of results. And there's only one file that's different than the rest. There you go. And I would put that in. Now, does this work every time? No, but if I'm like, and sometimes it bites me in the butt because it wastes my time, but it's better than me going and putting this in here. And to be honest with you, nowadays, all I would do is take this, put it in ChatGPT, say, hey, I want this to give me plus 25K. I probably, if you want me to be honest with you, the way you probably have to do it, which is really annoying, which is why I didn't do it, is size plus 25K. And then you probably have to do size less than 28K. Isn't that what it said? Less than 28? Smaller than 28K. And then there you go. So for those of you that were probably watching going, oh, he just doesn't know how to do it, I could have figured it out. I was just trying to take a shortcut there. So there you go. How many files exist on the system that have the back extension? Well, let's just do, we can get rid of pretty much all this. You can leave the execute ls tech la, it doesn't really matter. And we just want the dot back. And one thing you can do, you could just count them if you wanted, but what you could do is go word count, tac L for lines, I believe, 4. So there you go. So all I did there was put the pipe. So anything that, all the results from this go into a pipe, and then it feeds that into this command, which is WC stands for word count. And then I did tac L for lines so that it counts all the lines and then presents the answer, which was 4. Submit the full path of the XXD binary. Okay, well, this one we could just say, get rid of the find, and we can just do, instead of the XXD. Now, I understand what they're wanting you to do is probably do the which right there. I was seeing if that would work. So which in XXD, user bin XXD. Very, very easy. I was just curious if it was a, well, I should have taken the dot out of there for one, but all right, let's see what we got next. So file descriptors and redirectors. Okay. So this gets a little bit more into the weeds here, but you have your file descriptor, which is a reference maintained by the kernel, allows the system to manage input, output operations on the actual hardware. So it acts as a unique identifier for an open file socket, any other IO sources. So you have your 1, which is your data stream for input, std in. You have your std out for output, and then you have your data stream for output that relates to an error. Remember, we talked about 2 being the error code. There you go. So you can actually specifically say std in, std out, that type of thing. And you can see when they cat, think outside the box, they get think outside the box. And they're showing you here that the std in fd0, which is the input, that's the input they put, marks it as green. And then the output is 1, which is this red, right? And there's no errors in this case. So here, find etc nano shadow, or name shadow, and you notice they're going to get this find permission denied, permission denied, permission denied. That's your error. That's your std error, fd2. So that is going to be your error codes. So how do you get rid of those? The to dev null trick that we showed before. Here you go, to dev null, real simple. Redirect std out to a file. So this is very common, that you're going to say, hey, find etc name shadow to dev null. And you can put a caret there to redirect it into a file. So anything it would have outputted, it's going to put into a file for you. So that way you don't have to wait for it or whatever. You can run it in the background. You can go do whatever, or you can just save it, right? So find etc name shadow to, so any error codes put into the std error.txt. Any of the out or input put in the std out.txt, or the output, I'm sorry. The input's 0, the output's 1. So what they're saying here is you can specify, you can say, give me the errors in the error file, give me the output in the out file. And now when they look at it, see how it has them separate? So you can actually break it down to that level, which is really, really nice on Linux and really, really useful. Now, this is kind of an interesting one, right? So we've seen cat, right? Cat, whatever command, it opens a file. Well, here they're showing you, this is what it actually does. Cat the caret points to cat, stdout.text. I want to feed the std out into the cat command, right? So it looks backwards, but that's really what it's doing anyway, excuse me. Now redirect std out and append the file. So we can say find etsy name password, and you notice there's 2 carets. Before there's only 1. Now there's 2. That means add it to the end of the file, append it, right? So now the std out and then the 2dev null. So now they said, remember we already did it once. Now they want to add stuff to the bottom of the file. So now redirect the std in stream to a file. So a stream is until it sees this end of file. That's what they're showing here. So cat, everything until they see end of file, everything feed into cat, and then feed out this stream.txt, right? So anything he types, it's going to keep adding. It's just going to keep a stream going until it sees EOF, end of file, right? That's what they're saying. Now the pipes, we talked about this before. You take everything here, the whole command, any of the output, and you pipe it into the next command, which in this case is grep. Grep is a search function, and it will search for this system MD. So all the results, all you see is the ones with system MD. Then you have your file descriptors and redirectors. Okay, so you have find, same thing. We're grepping it into the system MD, and then we're doing word count tac L for lines, the same command I did already, and you'll see you get 6 lines. Same thing as here. You just don't see the results. You just get the lines. This is really useful. The word count is really useful when you're doing like a pen test and you need it to show proof of concept, but you can't display it because it's sensitive information. You can do word count on the file. The company can prove what's in that file, and you can show, yeah, this was here. So how many files exist on the system that have the log file extension? Well, let's do this. So find, we'll do this. We'll say, and I really could get rid of the execute, but it doesn't really matter. The log extension. Whoops, I did that. Okay, log extension, and we'll go ahead and say word count tac L, and we'll let it run. And 32 is our answer. So we piped it into word count. There you go. And you have to make sure you do the tac L. If you don't, it's just going to show you all the words, and there's going to be a lot more words than just 32, but that's the lines. How many total packages are installed on the target system? I don't even remember how we did that, or how they, let's just say, what command shows total packages installed on Linux? Okay, so, and you can see right here, we'll see if this actually works. You can see they're using grep tac C for count, but that's okay. We'll see if this works. May not work. Yep, it did not work. And that's because package wasn't on there. So we'll say, there we go. So apt list installed, and we'll see they're using word count list again. 738. So there you go. So they're just using apt. If you haven't used apt before, apt is the program, like you'll see a lot of times sudo apt or sudo apt get, whatever, sudo apt get install. These are the program that actually installs packages. And you can see if we look in there, well, this says 738. So actually kind of interesting because this says 737, but all right, guys, welcome back. So we're going to talk about filtering contents now. And yes, it is I had to stop recording, so that's why I'm wearing a different shirt. So I had to stop recording and come back to it. So first thing is, the biggest thing with Linux that I see people struggle with isn't the getting around day to day. They figure that out pretty quick. Just using it for a little bit, you kind of start to figure that out. Where you start to struggle, where you start to see those people struggle, is you're going to see them struggle with like, okay, I can't just control F and find stuff, and they're on, like, you can on Windows, and they start to struggle when they are like, hey, I need you to deep dive these logs, and they're like, well, I don't know how to do that. Like, it's that filtering contents and this is where you're going to probably get the most bang for your buck from this module. So the first thing is the more command. Okay, so the more command is used if you have like So you're going to see when you get into Linux, since everything is a file, some of those files get really long, like really long. And what you need to do is you need to be able to parse through it. Well, the more command lets you actually go through it. So I'll show you. If we go here and we say cat etc password, you can see it's not super long, but I do have to scroll up, right? Nothing crazy, but I do have to scroll up. But then if we go over here and we pipe that into the more command, we can say cat, we can just do that, etc password, and say more. You notice it says more at the bottom. It only shows me the lines that fit on the screen, and then I can hit space and it shows me the rest of them, and I can hit space and it shows me the rest of them, and it goes line by line, right? So you can actually do it that way. So the more command is super useful for that, because of the fact that you're able to actually go in and kind of go line by line. This is really nice if you're looking for something specific or anything like that. Now, it does show 10 lines by default. You can change that. Or I'm sorry, not more. I was thinking about head. Excuse me. More command does not show 10 lines by default. It shows what's on the screen, and then you hit space or whatever, and you can keep going down the line. Now we move to the less command, right? And you can see if we now take a look at the less, we'll notice that on the man page that contains many more features. This is true. So most people use less rather than more. Sounds counterintuitive, I know, but a lot of people use less. It's almost the same thing. It's just less has more options. So it's up to you what you want to use. If you want to see it in action, we'll just do the exact same thing, but say less. And you can see pretty much the same thing. The difference is I have this little colon down here where I can use all those options. That's pretty much the main difference, okay? So up to you which one you want to do. It says here, when closing less with the Q key, we will notice the output we have seen, unlike more, does not remain in the terminal. So it gets rid of the terminal. Gets rid of the output, which is nice. Can be nice. You might want it. I don't know, but I like it. So that we move to the head command. This is the one that head and tail is one that you're going to use quite a bit. You use the less and more quite a bit, but usually you're going to use one or the other. You're not going to use them both. Some people do, I guess, but I've never seen someone that's like types out more and then 10 minutes later is using the less command, because they do the same thing. So the head command. So the head command is going to show the top 10 lines. When I say top, whatever's at the beginning of that file, those 10 lines, that's what it's going to show. Now you can change it. So if we do this same thing and we say head, right, we're only going to see the top 10. I could change that and say I only want to see TAC 5, and now I only see the top 5, right? So you can change that, but the reason you do this is, let's say you know that you have this really long file, but you're like, I need to get to the top of it. I need to see the beginning of it because there's something at the beginning, right? This is what this is for, right? The other reason you do this is, the big one you're going to use the most is tail. And the reason I say this is I've seen this almost exclusively used by people when they're looking at logs. When you're looking at a log of anything, right, an Apache server or anything, right, as you're looking at that log, logs are coming in, right? Tail allows this to have the stream open, basically. So what that means is you can use the tail command on your log file, and you can watch those logs come in. So if I'm trying to troubleshoot something, I can have tail have that last bit of the files, right? And you can actually do that. Now, I will tell you, and let me make sure, I don't want to talk on my butt, but let me make sure. Tail command, Linux, does it show live results? Let's see if that's the right way to say it. Yeah, so you can see you can use the F follow option, and it will allow you to track updates in real time. So that's pretty much what I've used it for, is logging or logs. And the other thing is, like, 90% of the time when you're troubleshooting something, understand that it probably just happened, right? That's why you're troubleshooting it. So when it just happened, guess what? It's probably one of the last things in the log. So use tail to try and see the bottom of that log, and see what's going on. Now, tail and head, they have use cases, but as long as you know they exist and you can find them pretty quick, you'll be fine. Now, sort, right? So the sort command, this actually sorts depending on which results and files are dealt with, they are rarely sorted. Okay. Often it's necessary to sort the desired results alphabetically or numerically. So if you look, when they did put the Etsy password in sort, if you look over here, it's in alphabetical, right? So this isn't really useful in this use case, but there's a lot of times where I know I'm looking for a file that starts with a C, for instance, but I have a list of 10,000 files. Well, this is going to take me all day, right? I could grep it and do different things, but just sort them, and then you can look at them alphabetically. And you can keep in mind, you can combine as many of these as you want. So like, for instance, I can say cat Etsy password head sort, and you can see it's still going to put them in alphabetical and only show me the top 10, right? So you can put them in any order you want. You can combine them. You can do a bunch of different things like that. So then you have grep. Grep is one we've talked about already, but this is a search function. So if I'm, whatever the output of this is, so in this case, I'm opening the Etsy password file, I can search for, in this case, they're searching for bin bash, and it will show only the results for that bin bash. This is probably the most common search function that you're going to be using, mainly in Linux, because of the fact that 90% of the time, with everything being a file, it's really big, and you want to make sure that you have the capability to find what you need. And grep is huge for that, and we're going to see that here shortly. Now here, they're using grep tac v. This means everything but. So, for instance, the false no login, if you look, they're saying, give me everything except what has false no login. So if this line exists, don't show it to me. And so that's what they're doing here. So it's the inverse of grep, right? If let's say I have a log file and I'm looking for only things that were not successful, but there might be other errors in there as well, I could do grep tac v and put success, and it would show me everything that isn't successful, any other errors, right? Cut. So cut is something, this is where people get a little bit wonky or confused, but once you figure these out, this will save you so much time. So here you can see they kind of combined them all, right? They said same thing as before. Cat Etsy password, show the Etsy password file, grep that into a v, which mean, or into tac v, which means show me everything that's not the false login. So the output should look exactly like this at this point. But then they said cut, and they did tac d, which stands for delimiter, and they put this semicolon. So they're saying cut and use the semicolon as the delimiter, the spot where I want to start cutting, right? And then tac F1 stands for field 1. So this is the first field. So show me everything in the first field and then cut anything after this delimiter, which is the colon here. So all I get is the actual users. So this actually is very useful because there's a lot of times where you get on a machine, you're doing a pen test, whatever, and you don't want all this extra data because you're using, for instance, the Etsy password file. This is a perfect example. I'm only using it in this case to look at users. Well, I don't want to scroll through the users and look at all their home and directories and all this other stuff. Not yet, maybe, or maybe I don't really care. Maybe I just care about the users. So I can say cut delimiter. Here's all the users. And then I can also use that to show proof of concept that, hey, I did get the Etsy password file. I was able to take over the machine, at least as a user. Here's a list of all the users, and you didn't give any extra data away, right? Now, tr command, right? So this one has the possibility to replace certain characters from a line with a character defined by the tool. This is really useful for certain things that we're going to show here shortly. And so this is really useful for things like, hey, maybe like this case right here, they're replacing that semicolon, this semicolon right here, with a space. Why is that really useful? Well, look at how, if this is a huge file, look at how difficult that would be. So like we'll say cat Etsy password. Now it's kind of hard to make heads or tails of it. I mean, if you know what you're looking for, yeah, it's not super difficult. But if you had a ton of information in here, it's kind of hard. So if you say tr and you want to replace the semicolon with a space, now it separates them a little bit. Now, that might not look like a ton of help, right? But what if I did it this way? What if I said, hey, I want to do the semicolon as a new line, right? I want to replace the semicolon as a new line. Now, this is going to be a huge file, and you can see, oh, just put that in there because I didn't do it right, but that's all right. You can see it replaced it with the, there we go. There we go. I replaced it as a new line. Now, you might say, well, this isn't helpful. Maybe not on this use case, but I'm showing I can manipulate this data however I want, right? I could say every time a semicolon happens, I want a new line. Well, that's great because now if I wanted to, I could continue and grep for something specific. So you can see that I can actually use this quite very, very intelligently to kind of really start filtering out my data the way I want. This case, they're just showing the space because it's a simple, easy way to show it. Now the column, this one I haven't really had to use too much. Maybe it's just because I've never cared too much about the columns, but it is useful. You can see here they're using the same thing, replacing the so they're using that to replace the, there we go, to replace all the semicolons with spaces, but then they're going to say add this column tac T, and you can see if we do that, column tac T, and you can see you get a column for it. And this is even easier to read. So you can see you can kind of get very, very in depth with it, but all it's doing is making these columns, right? And the reason mine looks different than theirs is just because I have it so zoomed in, it's actually bleeding to the next line, but that's about it. So then you have awk. So awk is one that you're going to probably use quite a bit. It's usually my go-to, but you can use any of these. So you can see here, they're saying, hey, cat Etsy password, the same thing, replace all the things with spaces, and then they're going to say awk, right? Now, here they're saying print, and then they have this $1. That stands for the first field. So remember when we did cut, there was a delimiter field, and then it asks for what field we want to print. This is the same thing. We're saying print only the first field. Well, in this case, for the first field would be these names, right? Then they have the NF, and that is the last line, right? So you can see that would be this one over here. So let's say you only wanted, whatever. Well, the reason I like awk is because let's say I didn't want the last line. I wanted to know what users, and then I wanted to know their home directory. So I wanted this field, right? I would put print 1, then 2, 3, 4, 5, 6. So if we do it over here, we say we want awk, and then we'll say print, and we want the first field, and then we want the 6th field if I counted correctly. Maybe I did, maybe I didn't. And then, and it looks like I did count correctly, actually. Let's see. Yep. So now I have the users and their home directory, right? And if you look, you'll see the Hack the Box one was in here. Hack the Box, home, Hack the Box, right? So I was able to print, and by the way, this is the attack box, not the SSH, the box we were SSH into. I'm SSH into it here. So if you're wondering why the results might be different, that's why. So you can see the awk actually is really nice because it allows you to really kind of only display the fields you want, and allows you to then keep progressing, meaning let's say I only wanted these, but then I want to grep for something else, I can do that. So it's a way to really start filtering out your contents. Then you have sed, okay? Excuse me. So there's going to be come moments when we want to change specific names. So they want to change something. It's true. You're going to want to replace certain things. For one, you might want dummy data in there, especially if you're doing reporting. For two, you might want something that's very distinguished. Maybe you want to say, like maybe you're listing out all the IP addresses, and right before them, there's like something, I don't know, like it just says IPv4 or something, and you want to say IP address, right, for reporting. Easy. Well, what you can do, and you can see we're all the way up to where we were before. They said sed s/bin/htb/g, and if you look, that replaced all these bins with HTB, hack the box, right? Well, you might be asking, what the heck does that even mean? Well, the S, which is right here, stands for the substitute command. So we're substituting /bin, and we're substituting it with /hack the box, right? And then the G stands for replacing all the matches. So what we're saying is, hey, substitute all this and replace it with hack the box. Perfect. Pretty simple. Now, these use cases are a little bit more, we'll get deeper into your career, because typically you're not reporting you might be sending out information, but you're not creating the reports typically. When you start creating reports and stuff, especially in Linux, this will come in super handy, because you're able to directly just change the output rather than put it into the file, go in with like Vim or something and replace all of it. You can just do it directly from the output, and I don't have to waste my time. Especially if you script it, right? Like if you have a script that you're like, okay, every pen test we have these reports, or every whatever we have these reports, like I can script, just replace this, right? Now, word count, we've already talked about word count a lot. Word count actually just counts the words. Now they keep adding this tag L. It just says count the lines, not the words. That's the main thing. Okay, so we're not going to do all these practices, but we are going to do the questions, because I think their questions, once again, don't make a ton of sense from a